Istanbul is Fatih Sutcu. He's an assistant professor at the Earthquake Engineering and Disaster Management Institute at Istanbul Technical University. Professor, I know you're going to talk to us about seismic isolation technology and energy dissipating dampers. Most people probably don't even know what that means. So first, can you explain to us what it is?
Yeah, thank you. All buildings have structural systems. In a conventional building, the weight of the building is a vertical load and it's directly transferred to the foundation and the soil that the building is resting on. However, when an earthquake happens, the ground shakes in horizontal direction, which exerts lateral loads to the building. These seismic lateral loads are the main reason of damages and collapse in buildings. In seismic isolation technology, the structure is decoupled or, let's say, completely separated from the ground by the seismic isolation bearings in the foundation level. These isolators are basically made out of elastomeric rubber or curved surface metals. Isolators work like a roller and under the building, and all isolators are very strong in the vertical direction, so they can easily and safely transfer the weight of the building to the ground. But in the lateral direction, the isolators are very soft, and this way the damaging lateral loads of the earthquake are not transferred to the upper structure. This way, a seismically isolated building can survive a very strong earthquake without any damage, as for structural or non-structural components whatsoever. Seismically isolated buildings move very slowly during an earthquake, just like a very long pendulum. As for the energy dissipating dampers, you can imagine it like the shock absorbers in our cars. So these can be implemented in buildings, and during an earthquake, they will absorb the damaging seismic energy, eventually ensuring the building is safe and intact.
So do we have these seismic isolated buildings in Turkey? And if so, how have they performed in the recent earthquakes?
Yeah, seismic isolation technology have been developed since 60s, and the first applications were reported in New Zealand and Japan in 80s. As for Turkey, the first application started in the beginning of 2000s, but the number was quite limited by then. In 2013, though, the Turkish Ministry of Health have visited Japan, and after that they issued a regulation which mandates to use seismic isolation in governmental hospitals in the seismic regions with more than 100 beds. Since then, more than 50 very large hospitals have been built with this technology in the seismic regions of Turkey. These are very big hospitals with an average bed number of 600-700. As an example, there is this Pine Sakura Hospital in Istanbul, which have 2,000 beds with a closed space of more than 1 million square meters. There are other seismic isolated buildings too in Turkey, and these are generally airports or data centers. As for residential buildings, the seismic isolation applications are limited, but we have 2-3 applications in Istanbul, although I believe that after the last earthquake, this number will greatly increase. And I have seen a couple of these seismic isolated hospitals in the disaster region in this week, and no damage have been reported in these buildings. I've also learned that in the Malatya hospital, there was an ongoing medical operation, and they didn't even stop during the second earthquake, which was huge.
Wow, that is remarkable considering all the damage that we've seen. I know, Professor, that you studied in Japan, and I always think of Japan as being really sophisticated with how it manages earthquakes, because of course they have frequent earthquakes, and perhaps with the exception of the earthquake in 2011, they have relatively low casualty numbers. So how does this compare to Japan, and what can we learn from how they manage earthquakes?
Yeah, the number of earthquakes in Japan, it's very frequent. They frequently have earthquakes, so they have prepared for these earthquakes since many years ago. And also, as for the seismic isolated buildings, there are more than 8,000 seismic isolated buildings, and a substantial number of these are hospitals. We are not expecting damage or collapse in Japan after an earthquake. So generally, the casualties are from secondary accidents or some secondary disasters, or sometimes because of tsunamis. The seismic isolated hospitals serve as a medical disaster center after a big seismic event in Japan, and of course also for the surrounding cities. In Japan, this technology is also used for office buildings, for example, not only for protecting the building, but also for the occupants and the valuable contents. As for residential buildings, seismic isolated houses are very popular in Japan, and people are ready for paying more for these ultimately seismic safe buildings, even though the conventional buildings are also quite safe during an earthquake.
So do we have relevant codes and sufficient engineering power here in Turkey to build more of these seismic isolated buildings? Because it seems like they are necessary given that Turkey is very earthquake prone.
Yes, we have. And you see, seismic codes in Turkey have been updated several times in the past, and the most recent version have been published in 2018. This is called the Turkey Building Seismic Code, and there is a dedicated chapter for the design and the testing of seismic isolation. We also have very qualified engineers in Turkey who can undertake these quite complicated structural designs and conduct very sophisticated analysis of these structures. So we are ready.
Okay, it would be great to see more of those buildings being constructed here, and great to talk to you with some really valuable information. Fatih Sutcu, thank you so much.
Thanks.